Bismillahirrahmanirrahim. Dear students, today we are going to perform the experiment 3 of the logic circuits parts of the electrical testing 2. These experiments have two parts. One is the multiplexer and the second one is the demultiplexer. So right now we are going to understand the working of the multiplexer. Just before starting the experiment, what exactly the multiplexer is? We say that these are the combination logic circuit whose job is to perform the selection operation. What they are doing basically, from the many inputs, one of the input line is going to be selected and that will appear at the output for you. So in case of multiplexer, we can have two power n input line and we can only have one output line here. Also for the multiplexer, how we are going to perform the selection operation, it will be done by using the control inputs which we give the name as the selectors. So basically, if we have two power n input lines, then we need at least n selection lines to select from many input a single input that it should appear at the output. So in what we do in the first experiment, we need to perform the 2 to 1 line multiplexer operation here. So we need to use the as from your manual. We know that we are going to use a module which is KL33006 and we are going to work in the block E of this module. So as you see in the diagram, when we make connections, we have used the module KL33006 and we are working in the block E here. Secondly, what he said that now we need to connect A, B to data switches SW01 and 2 and selection C2, selector C2, SWC. So it's quite simple that we have connected A, B to the data switches here and we have connected the C to the SW2 as discussed here. Okay, also the output F3 is connected to the logic indicator here. Again, we have given the supply by connecting +5 with the +5 and common with the common here. Now what we need to do, we need to change the values here and accordingly we are going to get the output here. Okay. Now what we have basically, we are using these three input lines here and we need to change the values accordingly, and depending upon the output, if it is on we can put the value 1, if it is off we are going to put the value 0 here. So after filling here, what we need to do, for example, let me show you. Okay, let's suppose we say that let's suppose 0 0 0, we are going to get the output as we are going to get the output as 0 here. Okay, 0. Next one is 0 0 1. Again, when A is on here, the output is still 0. B is 1, we will get 1, then we get 1, and so on. Just fill it accordingly. Okay, just from the diagrams here. Now after doing this one, what we need to do basically, we need to say that, like for example, we say that for example we have three input lines. So out of these three input lines, one of the input line is going to be the selection line and the remaining two lines are going to be the input lines here. Now if you see here, we say that basically we've performed the experiment of 2 to 1 line multiplexer. So basically we have two input lines and we have one output line which will be always one for all the multiplexers here. This thing is going to change. Now of course if it is two input lines, so how many selection lines do we need here? We need 2 power 1, so it's like 2 power 1. So the value of n here is 1, so it means we need at least one selection line here. Okay, we need to say that, okay, for example in A, B and C, two of them are the data input line and one of them is the selection line here. So we need to decide which one is the selection line and accordingly we need to make the function table. Okay, how you need to make the function table, just quickly let me tell you how to make a function table. For example, we say that we are using we say that for example, yes, I'm giving an example. Okay, for example, I have only one selection line. For example, my selection line here is S. Okay, for some multiplexer. Now we say that whenever the selection line here is 0, the output is, for example, A input here. Similarly, when the selection line is 1, the output is going to be B. Okay, this is basically a typical example of 2 to 1 line multiplexer here, and let's suppose this is your output here, whatever output you have. So you need, from this table, you need to write it in this form here. Okay, so I leave it for you to understand this one yourself, to find out which one is your selection input. If you know your selection input, then it is very easy for you to decide which one is your output. A or B will be the output based on your selection input here. Okay, so this is basically, I want to see this thing in the report basically. Okay, thank you. Now let's move to the next experiment. The next experiment is about the uh, 8 to 1 line multiplexer. Now, in this experiment, basically, what we will be using, first of all, we are going to use the same module, but we will be working in the block F. So we are going to work in this block F of the same module here. Okay. Secondly, the diagram of this one is given here, which is exactly the same as what you have here. And next thing here is, if you see here, basically we need to connect from D0 to D7, means D0, D1, D2, D3, D4, D5, D6, and D7 to the DIP switch is 1.0 to 1.7 here. Okay, so it means that we need to use a DIP switch here. So basically this is the DIP switch, this one, this area. These are your normal switches, these are your DIP switches. They are working exactly as your switches here. Okay, what we will be doing here, for example, we have two switches. This is one switch, DIP1, then this will be the second DIP2 switch here. In DIP1 switch, we have total, we can give the input from 0 to 7, means we can total give 8 inputs here. Next thing here is, he said that the first button here, like here, this is your bit 0 here. So it means if I need to give input to something connected here, I need to use this one. Okay, so don't consider this one, the numbers down, forget about them, just only consider here, this is the bit 0, means 0, this is the 1, the next one will be 1, then 2, 3, 4, 5, 6, and 7 accordingly. So wherever you connect your input, for example, I connect from here and I connect from here, then you need to give 0 and 1 from these two here. Okay, the scheme is same. If it is down, it means we are giving logic 0. If it is up, it means we are giving logic 1 here. Okay, next thing here is, I mean, this is the circuit here. Now if you see here, we will give like inputs. Okay, he say from D0 to D7 we need to connect it into this thing. Okay, like, and secondly he said that we need to connect ABC somewhere. It's like here the input C to the switch 0, 1, 2, so you can connect them easily. Then this will be your output here. Now remember one thing, there is one output or one input here which is strobe here. Okay, now what we say that it is specifically written here, where if we want this IC, this is your IC, integrated circuit, if you want this IC to work properly, we want to give the strobe equal to 0. So it means if we want to have the output, this thing should be connected to the 0. So how it can be connected? One option is from here, you can connect it in one of these grounds here. Okay, so it will be connected. Or the second option is, you can take a wire from here and you can connect it in the TTL here and give 0 here, like this switch should be down here. So you will get the logic 0 here. Okay, so we need to make this connection, remember. Second thing here is, if you see here, I have F and Y, or maybe you can say W and Y here. Now both of them are your output here, but if you see here, there is a small bubble here, so it means this is the complement of your output. So basically Y will be my output here and W will be the complement value here. Let me show you here. This is your output here, this will be your output, for example. Okay, and this will be basically the complement value. So W will be equal to Y complement here. Okay, so whatever value, for example, if I have 0 here, I will definitely get 1. If this is 1, I will get 0. Means whatever value you have at the output, you get the opposite values here. Okay, so don't confuse that. Okay, like for example, in the table, I mean maybe in the next table, you are getting two outputs here. So don't confuse. Basically, Y is your output and W is basically nothing but Y complement here. Okay, and as we know that the output of a multiplexer is always 1. So this is basically the original output here. But this IC also provided you another output, which is the complemented output. Okay, Don't confuse. Basically, the multiplexer has a single output, which is basically Y here. Okay, so after let's make the connections one by one. Okay, step by step here. So first of all, what we have done, basically, if you see, let me go back to the okay, simple. Now, first of all, if you see here, the A, B, and C from here are connected to the data switches here. One connection, okay, because the connections here are very complex here. Not complex, I mean we have a lot of wires here. So I have just shown you step by step here. So we have connected A, B, and C. This thing we have connected. Next step is we have connected basically does D0 to DIP 1.0. D1 will be connected to DIP 1.1. Then the next one D2 will be connected here. D3, D4, D5, D6, D7, like here. Okay. Again, one more thing I think I missed in the previous slide. It is written as DIP 1.0 here. So 1.0 means this is DIP 1, and this 0 means we are talking about the input 0 here. So D0 will be connected in DIP 1.0, D1 will be connected in DIP 1.1, then 1.2, 1.3, and so on. Okay, so just connect them like the same thing in the same sequence connected here. Okay, next step here is the outputs here, Y and the outputs here. The outputs W and Y. So W and Y are connected in two logic indicators here. Okay, of course, blue here is W, which is connected in L1. So it means this is the complement value, and Y is connected in L1 here, and W is connected in L0 here. Similarly, we need to connect strobe here. So you can see I told you the strobe should be connected to the ground here, or we need to connect it in the switch and give 0. So I have right now connected in the ground here. Okay. So this basically concludes all your connections here. Now, how to check for the value here? For example, what we will do here when you give 0, 0, 0 here, okay? What will happen? The output, which is basically W is 1, and the original output Y is equal to basically here 0. What it means? It means that whenever I have the DIP switch 0, 1, and 2 equal to 0, it means that this is basically, let me again go back to for explanation. Sorry, brothers. Okay. For example, this is can I have a space? Okay, here I'm doing. Okay, this is 8 to 1 line multiplexer. In 8 to 1 line multiplexer, I can write it like 2 power 3 to 1 line. This is your output, okay, which will be basically Y here. This 2 power 3 are the number of input, which is from D0 to this 8 input. Okay, this is from D0 to D7 here. Okay, from D0 to D7. Okay, I mean D7 here. 7 D7. Okay, this is what I want to write. So from D0 to D7 are the number of inputs here. Now this 3 means I am going to have 3 selection line here. 3 selection line here. What are the selection lines? Selection lines are A, B, and C here. So it means depending upon one selection input, one of the input from here will be selected, and this will be displayed at the output here. Okay, so right now what is happening here? For example, when my selection lines here is 0, 0, 0, when this is 0, 0, and 0 here. Okay, so 0, 0, 0 means my first input, which is basically D0. D0 will appear at the output. So D0, what is the value of D0 here? This is your D0. Okay, this is your D0. So the value of D0 here is 0, and you are getting 0 here. This is basically the complement value. Okay, so if this is 0, this will be 1. So how you can verify that it is working properly? What you can do, for the same selection input, if I make the value of D0 equal to 1, so my Y should also become 1. So this is what we did. We make D0 equal to 1 for the same selection input, and it becomes 1 here. So when it becomes 1, obviously this is the complement value, which will be 0 here. Okay. Similarly, you can verify that for the same selection input when you have 0 0 0, if I change any other thing, any other input, for example, I change here, so there is no change. I mean, there is no change. Still, it's still 0 here. Why it is 0? Because my D0 here is 0. My D0 is 0 here, and it's still 0 here. Okay. So by changing this bit, nothing is changed. Why this is not changed? Because 0 0 0 is going to select only D0, nothing else here. Okay, so this is how you are going to verify here. And if it is working for 1, it means if I make it 0 0 1 here, so only I can change D1, no other will change with this one. Okay, so whatever input I give at the input line, that will appear at my output. Okay, like for example, yeah, this is shown here. Okay, when I make 0 0 1, so only D1 is be active here. So when D1 I make 1, the output Y becomes 1 here. Okay, so basically what you do here, basically you don't have to write the values here, rather you can say this is D0, because any value of D0, for example, if I have 0, it appears 0, like here. 0, it appears 0. When I make it 1, it appears 1. Okay, so and this will be obviously the complement value, so you can say this is D0 complement. Similarly, it can become D1, can become D1. This is D1 complement, then D2, D2 complement, D3, D3 complement, and so on. Okay, so this is the experiment. This is only the result here. Clear? So thank you so much. Assalamu alaikum.